Today is a very cool feature that was long awaited. I'm going to present in it. And once again, it will be heavy on demo. I'll demonstrate a few cases, or actually two cases, for traffic events logging. One is peer-to-peer case, and the second one is NetBird Networks case. The routed traffic, if you're familiar with NetBird, so you really know this concept. But before that, briefly about the NetBird, and this is an important part because there I will explain exactly these two cases that we have, peer-to-peer and NetBird Networks, and crucial to understanding of how NetBird login works, traffic login works. A very brief overview of traffic events login, and then, of course, demo with a few command line commands, and you'll see some TCP dumps as well. So stay until the end. There will be lots of interesting things going on. So NetBird, right? NetBird is an open source network security platform that makes private networking and secure remote access ridiculously simple. So you just install the agents and everything works. So that's the pitch line. But NetBird can be used in two ways. You actually see them both on this diagram. So the first one is a complete peer-to-peer network. When you install NetBird agent on every resource, on every machine, device, right? So for instance, here on the right side, there is a user laptop, and there is this little icon that indicates that there is a NetBird agent running on this laptop. On the left side, you have a file server and another server that are in some network. It can be a home network, for instance, but can be also an office network. Doesn't really matter. And a user tries accessing these servers, and when you run NetBird on every device, the agent creates a direct tunnel between these devices. So in this case, there is a tunnel you see going from here all the way to the file server, and also from the user all the way to the server. So that's a WireGuard tunnel, and that's a peer-to-peer use case. Usually it's used by our home users, home lab users, and when the networks are small, and when you can install NetBird agent on any device. Now, what happens when you cannot run NetBird on any device? And that's the second case here at the bottom. You don't run NetBird on these two servers, right? So you see that there is no icon, the NetBird icon. So, but you run NetBird on one machine within this network, and this machine becomes a connector to this network. And we call it a routing peer, through which the user can access these resources. And in both cases, the benefit is that you can close your network from the outside world. NetBird agent going to punch through the firewall and establish this connection. So in the second case, the WireGuard connection is up to this point, to the routing peer, and then it becomes regular internal traffic, internal connection. So in both cases, you can control access. So you can group your resources, group your users, and then say, okay, that this user can only access this server or group of servers. So similar, you can do the same thing you can do here in the home network. Now, what are the traffic events in this context? So traffic events and traffic events login feature is basically a way to improve observability in your network. What you can do with it, you can pretty much observe what's happening in the network, who connects where. So the traffic events are pretty much connection events. So say a user tries to access a file server via SSH, you can see this with the traffic events login feature. Or the same user wants to access a web server in the network, so that's the routed network. So there is a routing peer, and the user tries accessing this server, for instance, via HTTPS. So this is also something that you can see. There is another thing that you can see here as well, is actually a failed attempt to connect to a resource. And for instance, if user tries accessing a resource, a not allowed resource, this is also possible to observe with traffic events logging. So you can also see some unwanted access attempts. Now, I think let's just jump in straight into demo, and I'll show you how it works. Okay, so now here I already have a few machines, right? This is my MacBook, and that's the app that runs right here. Just a reminder, you can install NetBird on pretty much any platform: Linux, Windows, Mac, iOS, Android, Docker. You can run it on Raspberry Pi. So in this case, it's a MacBook, and there is also a server right here. That's a server that runs on a AWS in the VPC in Ireland. Let's see how the traffic event logging works. But before that, before I show you any connection attempts, I am gonna show you how to enable this traffic event logging feature. So you go to Settings, Networks, and enable traffic events. So that's the main one. And you see it is available from version 0.39. So it's a pretty recent version, even though it's now already on 0.45. But this feature was added like a month ago or so, or maybe a couple of months ago. If you want to see the actual traffic or the packets, the sizes, right, then you can enable this reporting here for kernel. And if you're using user space, that's fine. You don't have to enable this feature. So this feature will show you the actual sizes inbound and outbound traffic. Let's go back to peers and check whether I can access a server from my laptop right here. Now, to do that, I'll check the groups, right? And the server is in the servers group, and my user is in many groups. But the one that I'm interested in is IT administrators. And then I'll go to access control policies, access control section in the menu. And here I have a policy, this one, that allows IT administrators to ping servers. So that's exactly what I need. Now this policy is in place. I can then jump into the terminal and just quickly run the NetBird status -d command. Okay, you see that there is 1 out of 1 connected, and this machine is that server.netbird cloud. So what I'm going to do right now, I'm going to ping server. So I can either do NetBird server.netbird.cloud, or I can actually just ping server. Now you see ping works, and at this point, we should already see the traffic events. They are not appearing right away. It takes about a minute or so, but maybe before I'll show you something else. So I'll show you our documentation where there is lots of theory about our traffic events, and you can find it in the managed NetBird section, traffic events logging under activity. And there are a few explanations, and here's the explanation for the peer-to-peer case. It's very simple. A user from a laptop initiates a connection, requests a connection to a remote peer, and both machines run NetBird agents. Alice, in this case, requests a connection, TCP connection, port 443. Then the CRM system, the server, NetBird peer, receives this connection, and both of these actors, they log the connection attempt. So that's why when the connection starts, you will see 2 events. One reported from the original requester, and another one from the receiver. So, and this is what we see already here. They are a little unordered because the actual request happened like very fast. And you can see that my user, my machine, my peer, requested peer-to-peer connection to a peer server. And there is also a stop event, meaning that the connection was terminated and I stopped the ping request. So the same thing you see on the other side, that's the receiver, the server. So peer server received a peer-to-peer connection from peer Misha. And also the receiver shows the policy that actually accepted this connection. You can go here and see that that policy is active. Let's see what happens if I try accessing port that is not allowed. So in our case, once again, we have a policy that allows only ping. But now I want to call an HTTP port, for instance. So let's leave it here, and maybe we can use some TCP dump commands. I prepared a few. That is still my machine and my laptop, and I'll just show you the outgoing traffic. I'm checking the port 4443, and here I'll run an C command. Let's try this one. Do a server 4443. Yeah, we see here that the traffic is going, or this is actually in C trying to connect, but it's been rejected, right? So it will make a few attempts, and how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then all of these attempts should be visible in the traffic event log in the interface, NetBird interface. Now, I actually could have showed you the other side, the server, but maybe next time. So what do we see here? So it takes a little bit time, but as you see on this diagram right here, it can be also a block connection that is reported. Okay, meanwhile, while the events are being processed, and it's actually quite an interesting solution that we implemented. I think we might even create an article about it. So the whole backend behind this feature. So it's not a part of just a management service. So it's a separate service that collects these logs and does some enrichment of the event. So it's not a very like a straightforward feature, because you need to find you actually need to correlate the events. You saw that point here. Oh yeah. So yeah, you saw this part right here when there are two events that are actually correlated on the backend, and then there's a policy you have to enrich this information. So there's lots of processing happening on the backend side. But yeah, we see this blocked events, and that's an event per attempt of netcat. So if you had one request only, that would be just one event right here. Yeah, and it says that peer server blocked peer-to-peer connection from peer mission. So yeah, that's the port, that's the protocol, that's the destination, the server, and that's the source. You see also the traffic report right here. For example, in that one that actually worked, the ping one transferred 1,000 bytes and back 840. That's how the peer-to-peer connectivity works. Now let's see how the access to a resource would work. So right here we have a network. Oh, we don't. So we have to create one. And I remember that I was preparing it, but let's create one. So let it be an AWS RDS network. Oh no, sorry. Let's rename it to. Oh no, actually there it is. This is the VPC Ireland. That's exactly what we need. So that's the network, and there is an RDS instance, a demo RDS instance. It's a Postgres instance. Obviously, it cannot run NetBird agent. It's in a group databases, and there is a routing peer, which is actually the same peer that I was just showing you that I was trying to connect directly. And there is one policy here, IT admins to RDS databases. So I'm in this group IT administrators, and RDS database is a resource right here. So we should have this policy enabled. And just in case, I'll show you how it works. So I pick the group, the source group, IT administrators. I then choose the TCP protocol. Databases group is already selected. This is the group where our RDS instance belong. And I'll specify the Postgres default port. I'll just keep the default. Now I want to see the command line. So here, I'll just double check if I see this resource. Okay, it's available right here. That's our RDS instance. And if I run NetBird network ls command, that's the one to check the resources. And we see that this private name is resolved to this IP address. So now I will try to access this RDS instance. We can do actually the same with the TCP dump. So let's see the outgoing packets. And now, I think I saved this command somewhere. Yeah, right here. Connection succeeded, and this connection should have triggered the event as well. And in this case, when it comes to the routed traffic and accessing resources behind a routing peer, it works a little bit differently. So here you see the routing peer in the middle, and that's the resource. In this case, this CRM is actually an RDS instance that I showed you. So in Alice, that's me, in our particular example, tries to access a resource behind this routing peer. And routing peer will either log the connection attempt and forward the connection, or route the connection further to the resource that doesn't run the NetBird agent, or it will block the request, also report this event, and then just reject the connection. So in the same way as with the peer-to-peer case, this peer right here, this user, will report that it initiated a connection. So it's great that you have these 2 points. You can see, even if some malicious agent for whatever reason reports wrong data, you can always see a routing peer that is in your control, right? And on your infrastructure, and you can see what it reports. So you can always search events on both ends. So, and it works similarly to the peer-to-peer connectivity. So the event is reported twice. Let's see if we have an event right here. Yes, we do. So peer Misha requested connection to resource RDS instance on AWS VPC Ireland. And also I stopped the request because it was just a very quick and seek request. There were a few bytes transferred. And you can see also the second event. And this event is from the routing peer. And this is the indicator of the router. So that's the peer that reported the event from the router side. So that's the one in the middle here. And you see that the routing peer server received connection to resource RDS. All great. And then the same thing, it also stopped the connection just because I stopped it on the other side. Here you see the protocol, port, and destination. And that's the destination resource. You can see the full domain. You can see the resource name as it appears in NetBird. You can see the resolved IP address, port, and region unknown. So because we actually don't know where this resource resides. And I believe that in the case of a peer-to-peer connection, we see the region because it is shown for the actual agent, and we have this information. Okay, now what happens if we try to do the same, but with the port that is not allowed? So remember, I created a policy that allows port 5432, and right now I will try to access port 5433, which is not allowed. So still the same thing, TCP traffic, and but a different port. And let me see, what is it in the policies right now? Yes, this VPC. Yeah, that was the policy that we had, RDS policy. Okay, and back to the events. Same situation. There were a few attempts by NC to access the resource. You see it right here. All of them are recorded. So, and it is recorded from the routing peer. And the reason you don't see the second event from this end is because actually this peer doesn't really know if the event was blocked or not. Same thing, you see the traffic that was sent, right? And all of this, how many here? 7 attempts or 6 attempts, 7 attempts were recorded. One more thing I want to show you right here is that you can stream these events to other systems, like Datadog, Amazon S3, Firecalls, and you can analyze them later if you want to. So usually it's used with SIEM systems. We actually have a few integrations coming up. So we will have a generic HTTP endpoint, and I think it will solve most of the cases. So you will be able to send it logs to Elasticsearch, some other solutions, Wazoo. That's the open source one, pretty good product. But yeah, for now, there are 3 integrations available. I think that I covered pretty much everything.